morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co founder at Tech Scalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. Okay, so good morning, everyone. Let's get started. And thanks for joining us over a weekend. And let me set the agenda first. Let me explain what we're going to discuss. And today we have one of the longer session as such, where we get sort of more time to do the deployments and so on and so forth. So we'll be going into MLOps and we'll see the various details or various things, all the configurations as part of MLOps pipeline today. So my voice will get warmed up. So if it's low right now, it will get warmed up very soon. So basically, what we are going to discuss is that we'll understand what is MLOps. But if you have joined me for the previous sessions, we generally in the longer sessions we take a case study and we solve the case study. And while we solve the case study, we understand the concept and we understand all the pros and the cons or anything which we need to know about the topic or the technology or something like that, right? So today also I have one case study with me over here. It's a customer scenario. Uh, I have the entire case study with me as well. The entire case study will take you around 8 to 9 hours to solve and deploy. So that I will give you as the post session deployment. So whatever we'll do in the session, you can also deploy that in your environments, and but that will take you a longer time, right? So uh, that same thing I'll be deploying in next 2 hours as such, right? Okay, so we have the scenario of this customer called as wide world importers, and we'll read through it, but we'll be working with various related solutions. We'll work with Azure DevOps, with AKS, with machine learning services, with AML, with AutoML over there, MLOps, ONNX, and the Synapse is just theoretically there today. Mostly we are talking about the MLOps is the main theme of the session as such. Now I have the customer scenario open with me over here. So what we will do, we will first, I'll just set the theme, right? So because the problem statement needs to be very clear before we can start solving it. So we will spend maybe next 10 to 15 minutes in understanding the problem statement properly. And once we understand the problem statement, we will jump with the in the whiteboard designing and the deployment at the same point in time. So today is a session where I will be using the whiteboard a lot, and I'll explain everything over here. And the same thing I'll show you in the configuration as well, what needs to be done, how it's supposed to be done, all the individual steps and everything, right? Okay, so the customer scenario first. So the scenario is of this customer called as Wide World Importers. Now they provide solution for the manufacturers as such, and they specialize in identifying and solving problems for manufacturers that can run from the range of automating ways, any mundane task but time intensive task to they sort of automate that, and they deliver cutting edge approach by which it can be done. Okay, so the Wide World Importers has decades of specializing in data science and application development until now. were separate units. So this is the theme of the session, that they are experts in what they are doing, but the way they were doing it, DevOps was missing from it. So we have to basically unite, or we have to unify the data science and the application development, and we have to create that automated CI/CD pipeline for machine learning solutions. That's what we are. That's what we have to do for them. Now they have seen the value created by the by ad hoc synergy between the data science and the app development, but they, because like to unlock the greater, and they would like us to unlock the greater long-term value as as they formalize the approach by combining the two units into one. So now, as their first efforts towards this initiative, they would like us to define a process for operationalization of the deep learning models that you can say combines all the phases of the application lifecycle along with model creation, deployment of deep learning. So this is the one of the major idea which this customer is asking us to help them with. Now, uh, okay, so spatially, they are looking to leverage the deep learning technologies with NLP techniques to scan through the vehicle specification document to find compliance issue with new regulation. That's one of the theme which they have. Let me just quickly open the images which I downloaded so I can put things into perspective from here. So basically, this customer, uh, they, I'll zoom in into these images. I just, you can say, Googled for them over there, and there are a lot of images which I just want to throw and want your thought process to start from that point onwards. And let me just put one more over there. So the let me just see if I can drop the last one as well, or it doesn't want to come. Okay, it doesn't want to come. So now, so what we have here is uh, the and it's a real life problem as well. Basically, what happens? The vehicles, over a period of time, there are the various parts which we have in the vehicles. They get non-compliant because of various issues. Maybe there is some sort of environmental issue or legal issue, or some maybe so some of the issues are listed over here, and various countries have different regulations, and sometimes it's very straightforward. For example, it's based on the make and the model and the material which is used of that particular component in your vehicle. However, a lot of times it requires, if the car is pretty old and if there is a lot of changes which have been done in, you can say, replacement of parts has been done. So is this vehicle still compliant based on some regulation? For that, you have to go and get it reviewed from maybe a sort of I can put it as a mechanic as such, and or maybe some sort of authorized store, and uh, they will, you can say, give their recommendation, and then it will be either compliant or not compliant, and so on and so forth. So what this company want us to do is they want us they want that classification should happen automatically based on the inputs of the of the mechanic which is reviewing, or the person who's reviewing the component of the car. So that's what I have over here in this line when they say that. But today's main concept is not machine learning. We are concerned about the MLOps part of it. We are not really concerned about the ML machine learning part of it. Like, how is that model trained? We want to make a generalized machine learning pipeline, which you can say which can be converted, which can be used for various models. It's not just only for one specific type of regression or classification algorithm. It is something which can be used in various scenarios as such, with definitely with some customization, but we want to understand that. So, but the machine learning part of the solution is that uh, is of the compliance problem. So NLP for compliance, for classification of some text into various classes. That's the ML part over there. Okay, now Now, they are looking to leverage the deep learning NLP to find. So they want the NLP process to scan through the various vehicles over there, uh, scan through vehicle specification document to find the compliance issue with new regulations. Okay, now the first scenario is focused on vehicle components. However, the company believes that this approach can be generalized into any scenario involving inventory of components, such as their manufacturing customer deals with. So they expect that whatever we are going to do will be translating into other things which this company is also doing. So they have highlighted this point over there. They are saying that the component descriptions which are part of the free text are entered and managed through web application, and this web application will take new components description entered by the authorized technician and label the component as compliant or non-compliant. Okay, the CIO of the company is also having a few issues over there. They want us to ensure that overall process they create enables us to update both the underlying model and the web app in one standard approach, and they also want want to be able to monitor the model's performance, which we anyways were supposed to. We were thinking of that definitely the model performance should be monitored. Otherwise, how will we understand when the data drift happens? Okay, and they do not want the code to be littered with the usernames and password as such. That needs to be taken care of. So there are two major requirements of this customer. Need a solution that address the management of the entire model lifecycle, inclusive of monitoring the model in production and being able to retrain and redeploy when model needs updating, and a process that avoids checking the credentials into the source control, and credentials should be maintained separately in something like a key vault over there. Now, the I'll just put this requirement in the chat as well. Let me see if I can just copy that and put these 2 points over there. So if somebody has joined late, that's the main theme that we are solving, the last part over there. So we'll keep this page open here. I hope the problem statement is clear, that the company is looking for the MLOps pipeline for deployment of their models in production. They want to see how it's done, the process of it, all the details of it. And this time, the first thing they are starting with is NLP for classification for text, or it's a text classification based on the specification of the vehicles document over there. Okay, so now keeping that in mind, let's get started, right? So what we'll do, we will understand. I'll just see if my page, if the Azure portal is open or not. Let me just quickly go and open the portal as well over here. And I'll just close any unnecessary tabs which I don't need. So I have the configuration took me around. It took a lot of time. It around I think 6-7 hours to deploy. So each and every line which was there, that I have kept a lot of links with me. So I'll be sharing a lot of links in the chat window as well, and I will walk you through each and every you can say the depth of the concept over there. Okay, now first thing, let's open few of the definitions. I have kept it open with me over here, like what is MLOps and so on and so forth. So let's get that first over there. So I'll just walk you through a couple of definitions over here, and I'll keep on putting these links in the chat. This is the same link which I think Rashmita also shared a few minutes back, but I'll just put it in the chat again for you guys to. It will be in the chat window over there, so it's just getting there. You can use it later on. Okay, so MLOps is based on DevOps principles and practices that increases the efficiency of the workflow. Now, example includes continuous integration, delivery, and deployment. These three things needs to be done. Now, there are a couple of major points which we have to think of in our today. We have to solve that. A couple of major capabilities of any MLOps pipeline will involve the reproducibility of the machine learning pipelines. Things should be modular, should be reused. That's something which we also will try to do. Reuse the software components, register, package, and deploy models from anywhere. Uh, the data governance part of it, that's one thing we'll be focusing on. Notification and alerts in the machine learning lifecycle, that we will be configuring a few of them today itself. and automate everything end to end, and so on and so forth. And there is one thing which I want to go through. I think it's on this page over here. Yeah. So how is the MLOps pipeline different from other DevOps pipeline? There are four major points which Microsoft highlights over there that enables the continuous experimentation, comparison between baseline model. That's pretty interesting. We'll do that. Monitor incoming data to detect data drift. Trigger model retraining and set up a rollback just in case if something goes wrong. Create reusable data pipelines that can be applied for both training and scoring purpose. So these are the four points which Microsoft highlights that these are more unique to MLOps, which is not that unique to other you can say DevOps practices. However, the ultimate goal is still the same, that we want to provide the iterative or incremental value to the customer. That's the same process. That same thing still is there. That goal of the MLOps is to close the gap between development, production, and delivery of continuous incremental value, small incremental value to the end customers. So that thing remain there. Now, there is one diagram over here. We can have a look at it for once. This is what MLOps pipeline looks like. May or may not make much sense. So let's just have a look at this. Explore, experiment, operate. There are three phases over there: problem definition, data acquisition, EDA, experiment and develop. We have model selection, feature engineering, tracking, validation, testing, automation, and as part of operation, model serving, data drift monitoring, retraining, and monitoring. So this is how MLOps pipeline looks like uh, as well. Now, so I'll just minimize this. We'll use the documentation whenever required. Now, so if I bring you back to the problem statement which we have right now, to be able to uh, see to be able to practically work, we will be needing one repository, or we have to set up one repository, and this repository is the one which where all these so here we have the data scientists right now. We have the ML engineers also, and that red person is maybe it's you over there, and you have to design the solution today. So now if you practically think it through, right, like the if you think from the point of view of the data, and data engineers will also be there somewhere, which is not in the screen right now, just imagine them somewhere, right? Data engineers are creating the data pipeline. So uh, if we practically start thinking through the problem statement, and we will try to understand and solve it on the same point in time, right? So it's going to take some time before I can put everything in the screen, so hang in with me. Now, these data scientists, when they will be developing their solution, they need the development environment as such. The development environment needs to be somewhere as such. It might be their laptop, it might be in the cloud. Most probably it will be in the cloud as such, in a secure network. All the code and everything will be there, secure in the cloud, and they will be remotely connecting to it. So we are thinking of that, okay, we need some development environment, and this development environment is something in the cloud. Let's start from there, uh, like this. So that's one thing which we're looking for. Secondly, now anything which is getting checked in, we need a repository as well. So for repositories, we are using the solution which is in Azure called as Azure DevOps repos, which is basically the repositories provided as part of the Azure DevOps services. We'll see that in few seconds. Now, the purpose of this repository over here is for version control. All the configuration and the code needs to be version controlled. So I'll just say we'll do the version control over there of the code and the configuration as in these repositories. So the Azure Machine Learning Service which we have. So as part of Azure, there is a service called as Azure Machine Learning Service. So Azure Machine Learning Service is their primary service for ML purpose. Like like other clouds have other, you can say, major services which may come to your mind. Similarly, this is what Microsoft has as part of the custom AI over there. So if I go and start relating with what we have, I'll open my Azure portal, and I'll take you to the machine learning service. So this is how it looks like. Now, the development environments basically are on the left-hand side. We'll click on the compute option over there. And you see this compute instance over there. This is a development environment which we are talking about. So the first thing which we are looking for, this development environment, a secure development environment which can have CPU, GPU for the purpose of setting up, for providing the environment from where the developers or the data scientists can do the experimentation, is this one over here. So it can be CPU, GPU, pretty simple, straightforward thing. You create this. If I go to the next page, we have pretty advanced configuration here. We can do the scheduling for saving the money as well. Like it will start and stop at some schedule. And this is useful. We do this. It's basically the network integration. So everything is inside here, the Azure Virtual Network. Uh, and the network security groups, if you're aware of it, network security group is a type of firewall rules, or you can say source destination rules allowed in our rules, which we have in Azure, applied on the, it's a networking concept. So those NSGs will be applied on top of it. So it becomes pretty secure. It's in the control of the network team over there. So this will be enabled, and we'll deploy this. If they require, by default, if I just go back one page over here, so by default, it will be having these things installed over there. If the page loads, you see Jupyter Lab, Jupyter uh, notebooks, VS Code, RStudio, Terminal. But if in case they require something custom, we can totally provide it to them, and there is no need to install it separately. We can upload it. We can set the prerequisite. You can say we can set the configuration, so everything will be installed over there. You can have the RStudio Workbench installed, and you can also have any further custom things installed. For example, custom application, you can install it over there, uh, part of the configuration. Okay, now I'll just close this. So compute instance is the one which we are providing for the purpose of the development over there. Now, if I take you back to the Azure portal or to my browser, and if I find the correct page, so this is dev.azure.com. This is Azure DevOps. So we will be, if I zoom in over here, right, I'll go slower now. Okay, so this is Azure DevOps. So here, this is where we have to create this company wide world importers. They will create their CI/CD pipeline. So this is what we will be using. So for what they have to do is they have to come to dev.azure.com. They have to create the organization. Organization is name of the company or equal to the name of the company. And then project is a project. So create the project over there. And if I click on the project, I'll zoom out slightly. It's too zoomed in for me. I'll zoom in whenever required. So you see this project, for example, if we type MLOps 2 maybe over there, they will create this project. And as part of the project, uh, once this gets created, you see this like that. So that's the repo is over here. This is the repos over there. So what we have in the diagram like that is what we are going to help them over here with that. Now we can import the repository. We can publish. We can push an existing repository from the command line. We can clone it to the computer and so on and so forth. Basically, and what you can also do is you can go to the project settings, and over here in the GitHub config connection. So if you are using at the backend, if you have GitHub account, you can use it. You can connect with that as well. Now, the so if I take you back, so basically this company will click on that, and if I just take you show, so imagine if they have done this, right? So they have this repository, they have the project created, and now in the repository, this is their repository which they are using over there. So we'll also use this, and let me just duplicate the page couple of times. So we'll be doing a couple of things over there. We'll read through the code and we'll read through the configuration. So don't worry about that. Just hang in and understand. And anything which I'm showing, I also have it documented as well. So I'll pass the document. So when you have to reproduce it, you take your time and you reproduce it. So this is a repository. So we are setting this. We have set this for the wide world importers over there. So let's put that into place. This is there. The next thing is which comes into place is the full not the full concept of MLOps. So let's start understanding, right, how it will be done and what all we need to think of. So let me just make one. Let me just make two pipelines here. Maybe let me see if I can create a straight line today or not. Or not. Okay, so this is the CI pipeline, continuous integration pipeline, right? And this is the one, and we will be discussing all the things which are happening inside this CI pipeline. So continuous integration over there. Now the uh, so basically, as part of the continuous integration pipeline, there will be many things which happens in terms of the normal CI as well, and in terms of MLOps specifically. So we are more concerned about the MLOps part of it, like not the normal application development, but what specifically happens in the MLOps as such. So now there are various phases or there are various steps which will happen here, which we have to configure obviously, but so a lot of steps will happen. So we'll make some boxes over there to understand what are these steps. Now, if you practically think it through, even if you have to do any step, right, you need some computation to be able to do that. If you do a code check, let's say you do a code quality check, or you run any test as such, or you run any comparison of the baseline model against the target model and so on and so forth, like what was documented in the Microsoft's document over there, what was written, like we'll be comparing the baseline with the target and so on and so forth, right? Even if you do anything small or anything complicated, whatever you do, you need some computation. Without computation, and you have to pay for the computation practically. So what I'm telling you is that we need some agents, and these agents is the first thing which we need to understand or we need to create, and we are just going to call them Azure DevOps agents over there. Now, if you're using Git, let's say later on one day, if you use GitHub Actions, the same thing agent is called as runner there, right? There is no technical difference apart from that. Uh, Apart from the concept as such, but we have the runners over there. It's a different, you can say, we have done sessions on that GitHub action. You can go and check the previous sessions, or for today, we'll just focus on this. So we'll create the DevOps agent. Now, this DevOps agent is basically is a Linux machine. uh, it can be one or more Linux machines as such, based on how many things you are running parallelly. But if you have to explain it to somebody, or you have to understand yourself. So today's session is we are getting started from the scratch itself, right? So there is nothing which you can say, there is no prerequisite as such. So hopefully it will make sense for it to everyone. So there are two type of agents which are there. The agents which are Microsoft hosted as such, and the other ones which are called as self-hosted. So the Microsoft hosted machines are basically virtual machines which are created by them, and on those machines, the steps which we will create, they will execute on those machines. The good thing is you don't have to manage it. It's you can say whenever anything runs, it runs on a fresh machine, new machine. Uh, and you basically it's not your problem, you don't have to manage it. But the other thing is self-hosted agents. So in this self-hosted agent, we have to make the virtual machines ourselves. Virtual machine is just like a virtual server, so we have to make the virtual machine. The good thing about this is that you can have configuration, you can persist, you can enable the caching over there. That's one thing which I like, the caching part over there. So you can enable the machine caching over there, and we can also start persisting the configuration. So what happens, it boosts the performance. So we are also today using self-hosted, the self-hosted agent over there. uh, the and this is the one which will boost the performance. But what's the downfall? You have to manage it yourself. It will be, you can say, in your Azure subscription, it will be running. You have to configure it. Configuration is not very long. I'll just show the configuration to you. So these two options are there: self-hosted and Microsoft hosted agents. Uh, the self-hosted uh, further performs the you can say boost the performance by enabling the caching over there. That's what we are thinking of today. Okay, so if I show this part to you, how is this supposed to be configured? I'll just take you back to the Azure portal. So what I have done over here, let me just quickly retrace my steps as well. So what I did, I went to the agent pools over here as part of the project configuration. And this is the one which I have actually, which we are using today. But I'll just show you what I did. So I clicked on this add option, and I clicked on the self-host option over there, that I would like to self-host it. And you have to give a name over there. So let's give it a name. Uh, this is the self-hosted 2 over there. And I'll just click on create. So this is the one, for example, and then you have to say new agent, and then what type of agent. Will it be a Windows machine? So will this machine be a Windows machine where all the which you have to pay for, and which where all the configuration is going to execute? Which configuration? These boxes. Which boxes? That we will be discussing about those boxes over there. So Windows, Mac, Linux. Uh, what type of agent do you want? So I have basically clicked on this option over there, and then I followed the same step. I have the steps with me in my secondary screen. I'll just copy and paste the steps. I'll show it to you. Uh, and I took it from Microsoft's. I'll just show it to you from where I took those steps. I actually didn't follow this exact step. I followed the step from their documentation. So if I just go here, this is the Microsoft hosted. Then this is self-hosted over here. So if you come to this page, let me see if this is the correct one or not. Yeah, okay. So this link also goes in the chat. So what we basically do is we click on this, create the agent, and so on and so forth. Now there are a couple of things we need to do after that. There are a few commands which you see all these. Let me just copy the ones which I have executed. So over here, which I took this from this page only, but I skipped all the ones which I don't need over there. So this is what I have used. As such, I have installed the CLI client over there, the Azure CLI in the. So this is actually, I created a Linux virtual machine. Let me show that. I didn't showed you before. So I went to my Azure portal and I created one Linux virtual machine here called as MLOps agent. And I took the SSH of this machine, and then all the configuration happened inside this machine. So it is having two CPU and 8 GB RAM over there. So once this was ready, I basically went back and I went through all of this. And what I did is this. That's the agent. That this is the URL of the software or the agent, literally the client as such. This is supposed to be installed in that Linux machine. Then it will register with Azure DevOps, and then this is where we basically this is where the configuration started. Now, when you will run the configuration.config.sh, what will happen? It will ask for the URL of your DevOps portal. So what wide world importers will do is they will come and they will copy the URL of their DevOps portal, which basically is this URL over there. Copy and give it in the configuration when it will prompt in the over there. And after that, it will also ask for the PAT token, the personal access token. So you have to come here and you have to create this PAT token and copy the token like that and give it in the configuration. So what basically it does is, so we create the machine in Azure, and we install the agent. We do the metadata handshake, and finally it get registered. So once it is registered, uh, uh, it will show in the project settings over there. So if I can zoom out and if I can go to my project settings over there and to the agent pool. So this is the agent pool where everything will be running over there. Everything which I have done will be there. So agent, that's the one online right now. So it's idle and over there. So now, mm, okay, so this is basically the agent where things will be running, and this is what we are going to reuse also. Like this is what we'll reuse again and again. Now, as such, now once the agent part is done, like you have the location where the configurations can run. So we are talking about machine learning today, right? So where are you going to train the ML models? Where is your CPU GPU cluster? Where is your Spark cluster? How where will you do the distributed training and so on and so forth? So we in Azure have the custom ML solution which I was showing you a few minutes back, where we have the compute instances. So what we have to do is we will either get or create. So we will get it because we already have created it, but you can say get or create the AML workspace. That's the next step over there. So uh, workspace. So Okay, so this is basically the next step in the MLOps pipeline with Azure over there. Now, in this, why do we do this? What do we do with it, and so on and so forth. This is one of the ones where this is everything happens over here only. This is the workspace where you can say nearly everything happens in Azure. So if this box is representing that Azure Machine Learning Workspace, and if I can go back and show you in the portal where this is. That's the one which I was showing you first over here. This is the workspace. So everything happens over here, and we have to get it in the YAML file, or we have to get it in the configuration. So that part I'll show you. Like, what do you mean by get this, right? We'll have to connect to it. So that part will come in few minutes. So let's say we are able to connect to it. Imagine hypothetically you are able to connect to it. Now, once you're able to connect to it, if you want to use, you must have heard about various things like Databricks before. Uh, let's say you want to use Hadoop or Spark, and if you're using Spark or if you work with that, it's very Databricks is very popular, right? Azure Synapse is also pretty interesting. Databricks is also very useful. Uh, or maybe you are saying, no, I don't want to use any Spark based compute engine. I want to use maybe Horoward from Uber, and I want to sort of do my distributed training myself, and don't give me a Spark cluster. And you're saying, Shivam, just give me you can say the GPU cluster where I will do stuff myself. So anything, whatever you want to do, your training clusters and so on and so forth needs to be somewhere. So these training clusters are going to be part of this Azure machine learning service. Now, what we do over here is we give a configuration like this, like minimum 0, maximum something which you practically want. Let me just say 20 for now. But that maximum depends on you, right? On and or how much you can say on the capacity management which you have done. So don't worry about the capacity management right now. It depends on a lot of stuff as such, like how big the cluster should be. Uh, and there are a lot of concepts inside it. It will be way out of the maybe in a data engineering session that makes more sense. Okay, so now this is the cluster which we have right now. Maybe it's a CPU cluster, maybe it's a GPU cluster. We are not much concerned what type of cluster it is, but let's say we have it. It's part of that machine learning workspace. So this cluster needs to be created, or it needs to be, you have to either get it or you have to create it, sort of. So, or if it is already created and it is stopped, then it should start. When the step should execute, it should start over there. So I will just say create or get the AML cluster. Now, this AML cluster can be a simple cluster. It can be something like a Databricks cluster and so on and so forth. All those things can also be configured. There is nothing it's not very difficult. So now the, okay, so this is where we'll just say that, okay, this is where the model needs to be trained and so on and so forth. But the model training is not so simple, right? And this is MLOps. Here we have a lot of new things. So the main step which we will spend a lot of time into is we'll start from maybe from here. So where the training will start. So over there. So let's put one step. Let's say that we are going to run the pipeline. So I'll show you what is a pipeline right now. I don't mean CI/CD pipeline by this. I mean a different MLOps. I mean the machine learning pipeline in Azure. There's a different concept. We'll understand what is that. We will also version the data. It is absolutely required that when we do the build, the data also get versioned over there. So we will see how it is done. And later on, you can use the same code as well when you have to version it and so on and so forth. Now, then uh, we have to register it. So let's say register as such, register the model and the model if it is better. So this is we have to do one evaluation here that if the model is better, then it should register. If it is not better, uh, then don't do it. Basically, don't. You can say if it's not outperforming the old model, it should not be used over there. Now, so anything else which is left in this box, when we see it in the configuration, we will come back and complete the diagram. But for now, we'll just say that this is the step where the training is going to happen. The build is going to happen of your solution. over there in that box. So let's go to the portal and let's see how it's done, right? So we'll use this diagram for reference purpose. Let's see all these things which we have created. How do they turn out in the configuration? So I'll take you to the Azure to the DevOps portal over there, and let me just go one step back. Okay, so now hang in with me, right? Now just hang in with me. So if I show you, I just want to open a couple of things and let me see if I can arrange things in proper order or not. Uh, Let me just duplicate this page one more time over there. Okay, so check this out. So I'll go to the pipelines over there. Now you have to create the pipeline. The pipelines are taking a lot of time to run. Initially, they were taking 60 minutes to run. Then I increased the cluster size. You see this cluster size over there, this one. Then it started taking 25 to 35 minutes. So I already executed the pipeline. I'll walk you through the configuration because 35 minutes for that, I don't think if we can practically put it in the session. So let me zoom out once. This is the one which, so you just basically have to create the new pipeline first over here, like this. And then you will be clicking on the Azure DevOps, Azure repo. And this, what we are selecting, that I'll walk you through that. So we select that, basically the repository and the proper YAML file. But if I take you back to this, this is how it gets created. I'll just say edit over there. And we will be understanding what's happening over here. So if you see, let me just push that back. And okay, so this, what you see in the screen right now, this is actually what we have in the screen right now over here. All these steps which we just understood, that's what we are doing. So this part, the entire the CI pipeline is what we have over there. Like this. And there are various steps inside it, like 1, 2, 3, 4, like that, right? So like creating the agent is one of it, getting to the agent, connecting to the agent, getting connecting to the workspace, creating the cluster, right? So what we have here is what we have there. So let's understand step by step. And if I have missed anything in this diagram, I'll come back and I'll fill it up on the way, right? Okay, so Azure -pipelines.yaml file. This is the one which we have, and we are using that pool. That's the name of the Linux pool which I created earlier over there, as such. And this pipeline will get triggered if there is anything happens in the master over there, in the master branch. There are a few variables which are defined over here. Now I have these variables which are written here in the YAML file. One extra thing which we can do for you can say wide world importers is we can move them over here in the variable groups and we can use them later on. So that I think I'll leave it to you to go beyond it as such. Now, so we have few variables here. That's the name of my resource group where everything is deployed in Azure. This is the name of my machine learning workspace, the where the ML happens over there. That's the name of the experiment which we are using today. This experiment is it's there in the AML portal over here. So if I take you to this, that's the experiment it creates here. So sorry, this is environment, jobs over here. So this one, that's what we are creating. That will happen. Okay. So if we go back, so this is the name of the AML cluster. So AML cluster is that cluster over there. The name is AML cluster. This one. So AML cluster, right? The name of the workspace was the other one, the big one. And then there was an experiment inside it. So imagine some box over there where everything is getting logged. Logging is happening. Uh, Model name is compliance classifier, which we will understand on the way, not relevant right now. Uh, Kubernetes cluster is there. This is one of the deployment target which we are using. So the is it hard coded in the pipelines? The This is something which you I'll leave that up to you. So I'll give you that as well, like how to move it over here. It's not really very difficult. You have to come and you have to create the variables here like this. For example, this is my pipeline variables like this, and then you have to define them here. See, like this. over there and use the name in the pipeline. So I'll leave this up to you guys to do it. I'll give you the configuration for that. Now, once you have that done, now focus on this part first. Okay, so let me see, where was I? Mm, Okay, check this out. Now, name of the Kubernetes cluster is that. The working directory is over here. This is one more thing as such. So the steps basically starts from here. Now we'll just zoom in and we'll see what are we doing here. So we are installing the Azure Machine Learning CLI. There is a inline script which we are running, and this will install the Azure CLI.ml, Azure-CLI.ml over there. So what that does is it basically install the machine learning package in the agent. That's what it does. The first thing. If we don't do it, we will not be able to run any ML commands over there. That will not work over there. Now, the second thing which we are doing is the second step after that is, which we are doing, is called as attach the folder to the workspace over there. Now, what this does is Azure ML folder attach, and the name of the experiment comes from the variable. That's the workspace name, that's the resource group name, and if I can zoom out slightly, there is a path, build.source directory path. These are inbuilt variables, or these are inbuilt variables which are there in Azure DevOps. Uh, how will you do it? I'll show you on the way. How do we? I'll give you the link as well on the way, where all the variables are listed, and you have to use them when you are passing something from one step into another step, like that. So what this does is this basically sort of attaches the working directory into the agent over there. So all the configuration should be here. In this path, your configuration is supposed to be there as such. What configuration? The one which we have in the repository, all this configuration over there. Okay, now if I show you the specific part, now we basically, if you see this Azure Machine Learning create AML compute, and then the size of it, for example, some size, how many maximum nodes are there, how many minimum nodes are there. So this particular part is what we have over here, where we create the cluster like this. So either if it is already existing, it will not get created. Error doesn't comes. It basically just you can say moves forward over there. However, if it is not there, the cluster will get created over there in this step like this. So once this cluster gets created, it actually gets created over here. So if I click on the compute section, if I click on the cluster, this is the one, AML cluster over here, like this. So the size and the cluster and the location and so on and so forth, everything is here like this. So this is what we are defining in this line, that Azure ML compute target create AML compute over there. This is the name which we are using as such. You want to further parameterize it. Use the variable groups, put it over there, put it in the keyword, that further things can be done. Okay, now so we are able to connect to the AML cluster got created in that line over there in that step. Now after that, this is where the main thing happens. So we are running one pipeline now. Run training pipeline. This is representing that, right, where we have to spend a lot of time now. So if we just look at what's happening over there, then we'll go and read the individual steps. So we are executing this line inside the agent, inside the Linux machine, which says Azure ML run submit script. And that's the path where all the files are there, my pipeline master. That's my compute target. This is this one only over here. The experiment name is the experiment name in ML workspace. And then this is the pipeline underscore master.py. This is the main file which we have to find, and we will find it over here. So let me see, where have I put that? This is the one. So let's arrange the screen somehow, and let's go into it. So this is the main step which is executing over here, and all of these are the arguments which we are passing and if you're wondering how to parameterize something, this is how you parameterize something. So we'll understand. So we are passing the compute target name. We'll see what is that. The model name, we'll see what is that. Kubernetes name, as such. The build number is automatically will get inserted build number from the pipeline. This is a inbuilt variable. You can say these things. These parameters are you can these the values are created inbuilt when the things run inside the DevOps pipeline over there. So now let's see what is happening in the master.py. So this is the master.py. Now, see, one of the functionality of uh, MLOps, if you were listening to when we were reading the Microsoft's documentation, was that things should be reusable. Stuff should be something which you can say modular, reusable, uh, parameterized, and so on and so forth. Right, all of those things. So uh, and let me show that first. So if I show you something in the Azure portal once, you see this option over here. You see these pipelines. This is what we are discussing right now. This one. This is not MLOps pipeline. This is not the pipeline where we are doing the CI/CD. This is not that one. This is the one which we have now. We are discussing this box over there. So we are creating one Azure machine learning pipeline. Not we are not talking about MLOps CI/CD pipeline. We are talking about what over here, this small one, which is encapsulated inside the CI pipeline or the build pipeline over there. So in this pipeline, the concept is things should be modular, things should be reusable, and if you can parameterize stuff, parameterize it. Always parameterize it, and make sure that you have some individual components and so on and so forth. So we are creating steps over there inside that. Like inside this one step, there will be more steps over there like this. So there are two steps which we are doing. One training step, train step, and then we are putting you have to put one evaluate step minimum. You can further think I want to do more, make a bigger pipeline, it's up to you. No issues, but understand the concept first. So let's say this is the evaluation step over there. Now the so that so then what apart from this, what we have to do is, if you are running, let's say, step one and step two, practically think it through. Right, let's say you're running something step one and step two. Obviously you have to pass the data somehow the variables, somehow some value should pass from this to that. So that concept by which we pass the values is called as pipeline data. So I'll show you what is pipeline data in the code, but we'll just put it here, pipeline data. So pipeline data is the location where the first first step will write the output and the other one will read the input from. The same thing will go over there. And what is this pipeline data behind the scenes? It's an object storage. So this is Azure storage account over there. So this is Azure storage account, and which is an object storage. So object store. So the various steps which you have in your pipeline, now you can run your pipeline sequentially, you can run your pipeline parallelly as well. Which pipeline? This one which we are talking over here. And let's just complete. Let's put this box over here, and we'll call this as the name which we have given before. Let me see what name did I give there. Master.py. Okay. So this is the master.py. Master.py like this. Okay, now sequentially or parallelly, steps can be there. Can I have Spark over there inbuilt? Can I have Hadoop over there? Can I do something pretty complicated? Yes, you can do anything which comes to mind in that step, in these steps over there. So the data comes from here. This is the output, and then that becomes the input. And the middle location is the storage account, the default object storage. Now, when you talk about the training over here, right? There are a couple of things we have to understand. It's all about the data. So if this is my data, this is representing my data right now. We'll say data set over there. So if this data set was being used in this step over there, uh, and there is a train.py file, and this is where the ML code goes. So this is your train.py. So this train.py was there using that data set, and the training was happening in that location, right over there in that step over there. So just the code obviously you can say you will version control, but this data set also has to be version controlled. So because it's all about the data. After a few days also, which data set did you use before uh, to train that particular step on 5 days back, 6 days back, 1 month back? Everything should be traceable. That's one of the you can say uh, one of the principle which you have to follow as part of the MLOps. And I'll just practically show you how to do it. Right now, this versioning, it's recommended you do it with the build number as such. So we'll do it with the build number, no problem. We'll use that same thing. So let's see how this is done. So I'll take you back to the master.py right now. So this master.py is going to have steps over there. I think there are two steps only. If there are more than two, I'll come back. I'll remove this. I actually don't exactly remember how many steps were there. I have put two only. So uh, if I show you the main things over here, so if I take you one step back, you see all of this. You see all these arguments which we are passing from here, right? All these runtime arguments which we are passing, the model name and the build number and the Kubernetes name and so on and so forth. All of them are getting injected in this line. In Python, we have argument parser, arg parser like that. So this arg parser is taking those four inputs. See, AML compute target, the model name, Kubernetes name, and the build number over there. So at runtime, this is getting passed from the outer pipeline, the blue one, to the red one over there. At runtime, it's happening. Now, after that, so you see this get context. This basically means that uh, because stuff will be running, right? It will run soon. It's not running right now, but stuff will run soon. So the from here, it basically gets the run ID. Run ID basically means that in the experiment where we are executing it, where everything is getting logged, or it's like where is the logging happening. So the logging will happen in the current context or in the current run ID of the experiment. So that's what's happening over there. It will get the run ID. Now some normal things happens. The AML get the AML and so on and so forth. Uh, let's find something useful. Okay, so yeah, this is the main part over there. So you see this pipeline data. This pipeline data is referring to the default blob storage. The default blob storage is the one which you have over here, which gets created automatically. It should be in the data store over here. And one of them should be saying default. That's the one, like default blob storage over there. So the uh, so default blob storage basically you see this default get default data store. This is the object storage. This is a storage account. It's in my resource group right now in Azure. So will the data be there? Yes, we can go and check in some time. It goes over there. So we are saying that okay, you are the location where the input will write the output, and the second step will use that as the input over there. So it's the middle location where the data goes, the intermediate data. After that, okay, so now what we are doing is we are defining one training step, and then we are defining one evaluation step. Can I have more than this? Obviously, you can have more than that, right? You can have complicated stuff, but this I'm showing you when you have to customize your code, when you will use this template to run your own MLOps pipeline, where you have to make the changes, right? So this is the train.py. We'll go and we'll see what is this train.py, but this is the deep learning training code which we have over here, this one, and the model number, build number, and the output location. If you see, the output of the training step is that storage account over there, which is part of the pipeline data. This is the output location. So intermediate output goes there. Now, but nothing runs over here. So, and then we have this second step, which is called as evaluation step over there. And in evaluation step, we have this evaluate.py. So let's put this. This evaluate.py is very important for us. This is where nearly you can say the comparison of the models is happening over there. So we have this evaluate dot the evaluate.py over there. Now, uh, okay, so if you can see, so basically what we do is uh, after that, after these two steps, if I just find the next locations over there, In the meantime, let me show you this train.py right over there, this step. So what is the training? Where is the training happening? What other locations can I use? And so on and so forth. So we are discussing about this right now, where that file is being, you can say, is being executed over there. So let's go and find that, right? We'll go to the repository and we'll find it. It should be somewhere over here in this folder. And let me see if I can make the screen bigger. Okay, it's a normal deep learning solution. This is where your ML code goes. It doesn't have to be deep learning. You can, whatever you want to do, you do it. But basically over here, there are a couple of interesting things which we are doing. First of all, the normal argument parsing is happening. We are passing the arguments. But the main thing which we are doing over here is that you see this the data set which we are using for the training purpose. That data set which we have over here, uh, what we will do with that is we will just basically are registering it over there in this line. So what happens? The model definitely trains. That's a nice, interesting part. But for MLOps, the data set, you see this one over there, this is getting registered right now. So, uh, and the registration basically happens in this location. So over there, where we have the data registry, where everything get registered, that's where the registration happens. Now, this is where the normal, this is a Keras model. So you have this. This is the fit. This is the where the vocabulary, the index of the vocabulary will get created over there, and normal things will happen. This is normal ML code. I'll skip that. And then if I find you the next, this is where we are training the deep learning model. This is where we're designing it, not really training it. And we are converting into the ONNX, Open Neural Network Exchange. That's what we are using. And basically, that's what's happens over there. As such, now what we'll do, we'll just quickly go and check what happens in the evaluate step as well. Like, what's the next part over there? After this, the next is evaluate. So I'll take you to the evaluate part, and the this is where the next MLOps part happens as such. And let me just show you the lines. Okay, the most important thing is this over here, like this. So imagine that you have executed this before. So if you have executed this before, it means that the previous model which was trained was registered. Because first day, like day one, you had nothing to compare with, so you registered it. So when you registered the first time, it basically was what the model was registered over here in the model registry. So you have the old one with you. Now what you want to do is, if the new model is outperforming the old model, then go ahead. Otherwise, don't go ahead. It's a otherwise, don't waste the resources. Don't waste the you can say resources or the money over there. If it is outperforming the old one, then you basically do the next step. That's what we are checking. So we get the latest model accuracy. We get the old model accuracy from the AML workspace. We say, okay, get from there the old one. Uh, can it be accuracy? Can it be anything, any other metric? It's up to you. Which metric are you working with? Which metric have you saved earlier? It can be, if it's a regression will have different matrices, classification have different matrices. What you have there versus that you are comparing today. So that part is happening in this evaluate step. And let me just put evaluate over there. Now, if it is outperforming, then do the deployment true. Otherwise, don't deploy uh, as such. Okay. Now, just deploying is not it's not enough. So when you deploy it, or let's say when you save it to be deployed further, we would also be needing some sort of information about what have we done as such along with the model. So this is what we are calling as the you can say the metadata of the model, the model metadata. So you can see the title of the model, connected car classifier, the data sheet, uh, some details. This model was developed for automatically classifying car components which are compliant, non-compliant. The model tags over there, the timestamp when it was trained, the type of model which is there, classifier, build number, some run ID is there. What is your metric which you have saved? Any other URL for help purpose? Any other tag which you want to save? Use case out of scope, in scope, some caveats, uh, and so on and so forth. So all of this get registered with the model. So over here, we are doing the model.register. This is the model which has outperformed the old one. So, and then update the tag properties of the model. So at that step, basically what happens is what you will see on this page. I think not on this, the other one. Okay, this one. Yeah, you see this. This is all the properties of this is where we have the entire model registry. So, oh, sorry, yeah, literally the registry of the model. This is the model registry where we have the metadata of the model. So which build number is there? That's my build number. Why was it created? Who created that? Any specific information you want to log? Uh, what was the run ID? What was the title of this? What was the use case? And so on and so forth. What type of model? Which hyperparameters did you use? And all those details will be saved for you in that step. So this is happening over here in the evaluate part, where we compare and then we also saves the you can say the information about the ML model. So the metadata of the model get logged over there, model metadata, and the logging happens of that one. Now, if I take you back to the code over there, now okay, so let's go back to the pipeline over here. So this so what we are talking about right now is that red box over there, right? We are back in the red box right now. And those were two individual steps inside it, which we can sequentially or we can parallelly run. Right now it is sequential. Why is it sequential? Because you can see something like this. The evaluation should happen after the training step over there. So we can also put a wait over there, like you have to wait for it. When the training has done, then only evaluation can happen. Makes sense also uh, over there. Now, this is where the pipeline actually starts executing. This is when the execution really happens of the pipeline. Till now, we are just defining the configuration, which can be reused later on, modular, and so on and so forth. So if so, is it something which I can reuse later on? See over here, if I take it to the pipeline section, we will be able to reuse it later on. We can see it here as well. Let me see which one will it be. We'll randomly click somewhere. So you see this like that. So there are two steps right now in this pipeline, training and evaluation step over there, uh, which are there, which we can actually save here also in components, like individual code components, and those code components can be used. This I will leave up to you guys. You guys are will be experts in this in few months, or already are experts in this. So I'll leave it this to you to configure in the code components. However, if I just take you back to what I wanted you to go through over here is the the master.py, and the this basically is uh, done. Okay, so now this is where the entire training happens, right? This one step is where all of that happens. The after that, what we have to do is we have to think about the next step. So if CI is done, we have to think about the continuous delivery and the and on what basis do we have to trigger it and so on and so forth. So you have to save, you have to specify the source location and the target location for your artifacts as such. Now what I'll do, I'll just show you something which I have opened for you uh, as such. I kept it open over here. Let me show you this thing in their documentation, the predefined variables which are there. And this link goes in the chat. The one which we are using over there is, let's find the one which we are using, the artifact staging directory. Okay, let's search it here. Okay, so what it basically does is that it is the local path on the agent where your artifacts are copied. So everything is happening in that Linux machine, which we created earlier, right over there. But that's not the only one. If you, we have more of them. We have the source directory, and we are using that over there. Apart from this, so it should be somewhere here. The it's basically the sources directory. So let me just put the sources directory there. Okay, this is the one, the build.sources directory. So these are the predefined internal variables of DevOps, Azure dev.azure.com for us to use. So basically, it's the local path on the agent. That's what it is, the local path on the agent. So what we are doing is we would like to copy that artifact from that local agent because that agent has to be deprovisioned. Why to keep it running, right? It's if nobody's using it, should be deprovisioned as well, right? So what we do over there is we copy the file from the source to the artifact staging directory. And that is the one which we are finally and which we publish as, and the name by which we will publish is called as DevOps hyphen yeah, DevOps for AI over there. So later on, if anyone needs to find it again, this is the name by which we can find that particular artifact number and so on and so forth, and the artifact which got created for us. Now, what is this artifact and what are we thinking of in that step is that the uh, so the output of this pipeline is the artifact. Now, the artifact for us is the trained model, the registered trained model, the one which got registered. If it doesn't outperform, it's not useful for us, right? Over there, which we have defined over here in this step over there. So now we are saying that okay, now you got trained, but we are not sure whether we also did the evaluation. We really did the testing as well. Like we evaluated the performance of this one against the old one and so on and so forth. But is the API endpoint created? Is it properly running over there? See, just having the model will not deploy it, right? You need to have it in some sort of Docker container. It should be containerized. All the dependencies should be there. If I deploy this in production, I should have the confidence that it will work over there. Infrastructure as code, and everything will come into picture. So there are lot of more things which are there. So we'll just make another pipeline here. And this is the one which we are calling as the continuous delivery one. So now, okay, first step remains same. You have to connect to the agent. That agent is the one where all the steps are happening for us. So that's first step will still be same. Create or connect to the agent or get the agent over there. So I'll just make one box and I will say that I have to uh, create the DevOps agent. So let's say get or create the the Linux VM, which is the agent for us, right? Which already is there, but that's what we are using now. Okay, so the CD is going to execute on this machine over there, which we already have configured. It's running happily right now. Its metadata handshake is done. Now, to get the confidence whether this is going to work or not, we have to test it out. Now, if you work with Azure machine learning solution, one of the most common testing location where we do the model deployment to see whether the API endpoints are running, whether it is how it's going to, is it everything is packaged correctly or not, is basically ACI, Azure Container Instance. So that's what we are also going to use. So we'll say deploy to ACI. So we have to create it. Now, this is where your infrastructure as code will kick in. We don't have those environments with us. We would like to have the environment. We would like to do the testing with some API endpoints and so on and so forth. So this is where we are creating the Azure Container Instance. So like this, but this Azure Container Instance is for those who don't know what this is, it's basically a location where we run the Docker containers. It's not production grade. We avoid this in production because it doesn't auto scale. That's one issue with it. Uh, so, but in production, if you if it is feasible in your company, you can prefer a Kubernetes, but still this can be used as the testing location because it will provide you a similar environment, not same environment, but similar environment in a you can say more uh, less costly environment. Okay, so what we practically have to do is we have to create that ACI instance first, right? That needs to be created. Second, this is a Docker container. The container doesn't exist, right? We have to create the image, and the and what should be there inside the image? Our model should be there, machine learning model. The which one? The last one, the best one, which got registered in the previous as the artifact in the previous step over there. So I'll just put some version number. Dependency should be there. Otherwise, it will not execute over there. And we also have to define one score file, the entry file, like where the entry will happen. So this is score file. You can call it at main.py, score.py, entry.py, call it anything. It's just the entry point. It's the entry point in your program over there. Now, there are a couple of more problems. We don't have the rights. So what we do, the DevOps pipeline doesn't have the rights, will not have the rights over there. So we go to the Active Directory. We say Azure AD, come here and help us out with this. So in Active Directory, we create a concept called as service principal. So we create this concept called as service principal over there, like this. This service principal is the one which is connected over there, and this is the one which is having the rights over there. So I'll show you this configuration as well, the RBAC over there. What is the service principal? If you are not aware of this is equal to, you can say it's the representation of your application in the directory, or in easy words, it's the account by which it will execute, it will run. So like a service, not really service account, but similar to that. For this understanding purpose, we can say that it's similar to that. Okay, but that doesn't solve a problem, right? See, now after this, what we will be doing is we have to test it out, right? So we'll be doing some API calls over there, and then so imagine this is the test.py. And this is some you can say job which is running, which is doing the API calls, and we are doing the testing over there. Now we want to see whether it's running fine or not, and so on and so forth. Uh, and we have to sooner run this in production also, right? We won't be changing the configuration. It whatever we are testing will be deployed over there. So here we will enable one logging process over there. So what this logging process will do is whatever input API data is coming right now in testing environment, then in production it will come. Whatever input API data is coming from in real time, that needs to be logged first. We need that. We need that to understand the drift in the data later on. And apart from that, whatever predictions are going back, that also we require. We would like to see the predictions which were done on the input data. It will be useful for doing the model retrainings, or during, you can say, tracing whether your model did something good or wrong over there. So these a couple of things we have to do over here. We have to, so if I just summarize what we'll be doing now, is we have to create the ACI instance over there. We have to understand the score.py file. Why is it there? What's the purpose of it? How the model comes over there. How are we defining the dependencies over there in this uh, for the container to be created? How do we define this? How the service principal comes into existence? How do we make that? And how do we do the logging over there? Why are we doing the logging? So we can know what is happening in production, like that. Right now it's testing environment, but we'll be doing that production deployment as well. So if it runs here, then it will run there only. So we will check this out. And the location is the same old location. We can use storage account for the logging purpose. Storage accounts where everything is getting logged. But the service which will do this is application insights. So we will do the service application insights, and we'll see how we are using it. But I'll just put it here in the screen. Let's go and see how we configure this part. Okay, now let's zoom out. So this time it's the time of the release pipelines. So we want to see the delivery of the application. And I'll zoom out a little more. Okay. So this is the one which I executed last night before, I think, sleeping. Things fail, right? That's the one. So let's click on edit and let's understand. Okay, so first of all, when will it execute, right? So this is one trigger which is kept over here. I'll zoom out a little more. Okay, so the compliance classifier is actually the name of the, we are using this this is referring to the name of the model right now for us, compliance classifier. This actually is representing this over there. So if the artifact get registered, then it will trigger. That's what will happen. If the artifact get registered, then it will trigger over there. So now if it gets triggered, then what happens after that is the test deployment part over there. In this test deployment, we have two steps. A normal step where we are installing the machine learning CLI, Azure CLI for machine learning, where in the agent, which agent? That agent over there. So the CLI gets installed over here. Then after that, after that, we are using this. You can click on this plus icon. You can search for AML. You can drop this. What basically it does is it is the AML deploy step over there. Now you see this service connection. So this service connection actually, what I did, I created before that. So I went back to the project settings over here and I zoomed out so I can look at the screen, and I found the service connections here, this, and new service connection, resource manager, next over there, service principal automatic, first one, next, machine learning workspace. Don't give more permission than required. So machine learning workspace, resource group name, that one, name of my workspace, MLOps. That's the name of my machine learning workspace, and the name of the service connection over here. So when you will click on save, what it does is this. It basically goes to the Active Directory, and it goes to this step over here, app registration, and it does this for you over here. One of them is over here. Uh, One of them should be the one which I have there. Not sure which is the correct one. We can trace it if required. It can be traced, like which one is it. So the one which we are using is the middle one over here, quick start -sc. Let's see if any one of them says that. Quick start -sc. I think this is the one, quick start something something over there, like this. So what this means is that dot in the Active Directory. This dot is having the rights uh, which is required for the DevOps pipeline to deploy something in my resource group. That's what it means. So once you create this, you come back and you have to use it. So let's come back. That's the service connection. And the okay. So if you notice this inference config path and then this configuration file. So let's see what are these two things. First, what is this inference config.yaml file, which we are passing over here? So to understand that, we are just going to go one step back. And let's see where is that inference config file. So, okay. Now notice this, a little complicated here. Looks small, but it's not really small. Entry script is score.py. Okay, great. That this blue one is the entry script. Oh, okay. That's the one over there. It's there. Runtime Python environment to create the green box over there, the Docker environment, the Docker container. That file is here. This one you have to define it. Then do you need GPU? No, we don't need GPU and so on and so forth. If you need GPU, you can go for it. So if I click on this one, so score file, and we'll see the environment file over there. So score.py is the file which is the entry function, which will initiate the model over there. Environment is a smaller one. Let's read the smaller one first. So the smaller one, basically this environment file defines the environment, like uh, 3.6 and everything over there, TensorFlow, Keras version, and so on and so forth. Now it's very important that whatever we are doing should be version controlled. So what we also do, this environment file, we register in the environment section over here in custom environments over there. I think this is the one, or maybe you can basically register here, but this is not exactly that one. This is a different one. Okay, so you basically can register it over here. You can click on create. You can upload it from the, you can simply say create from the conda file or the existing Docker context over there. We can register the environment over there. So if I go back And if I close all these unnecessary tabs right now, so you will notice that this is the file which we are going to. This is the one where Docker environment is defined. Then this is the one where rest of it happens. So there are two main things to understand: initialization function and the run functions. These two main things are there. So if I zoom in and let's go through it. So in the initialization function, the model gets loaded initialized assets. That's one of the main thing which happens. The name of the model is compliance classifier. So what it does is it gets the latest artifact which is there in the machine learning service. So it gets it from there like this. So it you can say it pulls the latest classifier. It will search by that name because it's possible that uh, the you don't have to hard code it. You can pass the parameters. So get the model path from it. So this model is part of the Azure machine learning core as such. So it will get the model path, and we are using Open Neural Network Exchange. So there's a runtime for that. Now after that, model collect data. This is the important part. So you see this model data collector. Let me show this class. I think I have kept it open somewhere in my secondary screen. So check this out. This is the important part. This is where that logging happens over there. So we are using this model data collector class. So what it does, it defines a data model data collector that can be used to collect the data in Azure Machine Learning Service when you're deploying a web service like in Kubernetes and so on and so forth. We are not using Kubernetes in this line, but we will use it later on. So and it does it to the blob storage over there. So this is this is that red line. So it logs the input which will come finally in the production and the predictions also. So both of them we are logging over there. So if you see, we have the inputs and we have the predictions also. Both will be getting logged, and we'll call them as model telemetry. And this telemetry I'll show you in few seconds. Now to create the vocabulary, we are creating the vocabulary over here. Basically, the index for the vocabulary is getting created here. It's a uh, over there. And this is the run function after that. Run function is the one where model.predict happens over there in the run function. So if I scroll down and if I can just scroll down a little more over here. So this is a Keras step as where we do this is an NLP step where the sequence is getting created. So if you see over here, this is the function where you can say we save uh, the input into the blob storage. This is where we save the output into the blob storage. And over there in these two steps as such. And the so after this, what you can do is you must be having a way to test it out. So that I have not automated it here. It's just one notebook which I have in my Azure Machine Learning service where I have the testing part going on. I think this is the one model telemetry data. So we just you can say you see this compliance classifier. So the way you have to do it is once that uh, you can say once the CD part happens, once it gets deployed over there, right? So let's see how does it get deployed. Then I'll show that part. So so the next thing is ACI deployment config.yaml file. And if I just come back and show that part here, so it's a very small file. What it basically says that there are 3 CPU cores and 15 GB RAM in the ACI instance that will get created. So once that gets created, and once you go and you do the testing with it, right? Data will start getting logged. So you can go to your Azure machine learning. You can say you can go to your resource group. So I have, let me go to the resource group. So what I have done is I have configured one application insights over there as the receiver. So this is the MLOps application insights. It's a monitoring service. Basically, what it does is application monitoring. So I'll click on logs, and there I have kept one query for you in the other section, request ML query. And if I click on run, it runs on 24 hours of data. So these are some API calls which I have done previously. So everything is getting logged over there. Uh, the you can say the you can say a lot of information is getting logged. As such, you can pick up the ones which you can say which you require more than the others, uh, as such. But finally, so this is actually that one, this step. Now, if everything is fine, we would like to take this to production also one day. So, and here I'll just extend my pipeline and I will close my pipeline like this, like that. And the next step is the Aks deployment, Kubernetes deployment. So this can be existing. So let's say most probably it will be existing. So let's say uh, get Aks name and all that for deployment, for deployment. And this is what we are understanding as the production environment as well. So what we are doing here is like one human approval like this. So if I take you back to the machine learning to the MLOps pipeline, I'll take you back to the release one, and the one which I have here. We'll click on edit again. So what you need to do is you basically need to click on this option over here. And now you can do all type of things here. You can have different triggers, like what will trigger it. You can have a human pre-deployment approval as well. So I have given my email ID there. So when the email goes to me, I click on the email, then it further executes from this point onwards. There is a timeout of that, and you can have other settings as well done in this step. So what happens in production? Same thing. We have two steps over there. First is install the CLI in the agent over there, and then the next step is the AKS deployment. So this Kubernetes cluster can be existing, can get created also if you really have to create it. But if you see, what they have given is they have given these options which are inbuilt over here. Like this step is specifically designed to deploy there in AKS or ACI over there. So if I change it, it changed the configuration for me. So the name of my Kubernetes cluster is this AKS cluster 01. This cluster is the one which I have previously created, and it is happily running over here right now as part of inference cluster like this. This is the one over there. Either it can get created or can be fetched for you in that line over there. So now you have to define the configuration, like how big the cluster should be, and so on and so forth. So if I just show you that part, it's hardly 3-4 lines are there. So I'll just click on this scripts, config, mm, AKS deployment config. So type of compute target, Kubernetes, um, authentication required. So authentication required will generate the API key. I'll just show that in a second. Application inside enabled over here is false for it. Scoring timeout, uh, and so on and so forth. Any other information you want to define over there, you can define. Now, once this executes, then the endpoint gets created in the endpoint section over there. Everything is version controlled here. Like we have the endpoints here. So if I click on this endpoint, this is the endpoint for ACI. This is the endpoint for Kubernetes. It's written in this column over there, Kubernetes and container instances. So that's the testing one. This is the this one over here, the one which we have right now. From where is this name coming? We have defined it. So if we go back, we have defined it in somewhere here like this. So deployment name. This is the same name by which deployment will happen in AKS also. So once this execution happens, uh, the endpoint gets created, and the consumption points are here. The API endpoint is this one, and the key is over there uh, for the production consumption over there. And this actually gets created. So if you go to the Kubernetes cluster over here, workloads with that same name, you will be able to find it, trace it, and further work with it. This is the one, compliance classifier hyphen services over there. This one. So uh, this is the one which where it is running in production. So I'll take this point over here, and that's the Kubernetes cluster. where finally it gets deployed over there. So Aks deployment like this. Now, and if I'll just correct this. So this is continuous delivery till here. And now because we are going in production, so we'll just make this arrow go a little more. So this is the continuous deployment part over there, the CD part. Now, the one of the so we have sort of designed one. You can say pretty. It's a simple one, but still you can say pretty useful MLOps pipeline. But how do you do the retraining and so on and so forth? So for retraining, first of all, we should know that we have to retrain. So if you see this logging which we have done, right, like this is one of the input which we take over here from there. So that is called as the target data set. So that is the target data set. Now it needs to be configured. It's not we have done it. I didn't show you, but we actually did that. So if I take you to machine learning studio, if I click on my data set, uh, this is the source data set. This is the target data set right now. Inference data compliance classifier one, the classifier service. This is the one where the logging is happening. This is the one which is representing that where the logging is happening. This is that. And it's in my storage account. There is a container in a storage account called as model data, where this is existing right now. So if you go to the storage account, as such, over here, container, model data, like this, it should be somewhere in this one of these folders. So MLOps, Shivam, compliance classifier, telemetry data, default, input prediction, input 2022 06 month, day, input.csv. This should be the one, input.csv. So this is the input data which came on the API call over there. So if we look at that, it says manufactured in 2016, made out of plastic in good condition. It's the description of the vehicle as such over there. So this is the input data. The prediction is in a different folder. So this is, and here we have information about the classifier, like which model, what ID, and so on and so forth. All those information is there. The prediction is here in the previous folder. So you want it to be in the same folder, you can just make it. I'll just go one page back. Let me see. Okay, it went all the way back. So the predictions are in the other one. It's over here, like this. So day, it's properly partitioned in terms of the source location. You have years, month, weeks, day, and so on and so forth. You can do all of that. The prediction.csv is this one. So these are the predictions which are going back now. So what we do is we would like to understand whether the data drift is happening or not. So the data which we have logged, this data over here, which we are calling as the input data, right? Data which was coming over the API call. This is the one which we are calling as the target data set. Uh, we can call it as a target data set. You can name it something else also. And the data on which you have done the model training, which is actually registered there. You see this one. So over here, the one on which you have done the model training, that is the baseline data set. So this is the baseline. So baseline data set, and this one is the target data set. Okay, so what they have done, see, uh, every cloud has some services for data drift. Azure also has it. You don't want to use Azure, you can write your own scripts as well. You can maybe, if you're doing the data drift in NLP, you can find the word embeddings, you can find the cosine distance between them, or you can have, there are different logics of how data drift can be done. So what Microsoft did, they actually created one service out of it. They said, okay, let's make a service out of it, so it becomes as a service. So we call this as data drift monitor. Now, this data drift monitor is the one which needs to be scheduled. You have to schedule it. So it will run on some day as such. You can whatever frequency you want, you define it. So it runs on that day. What it basically does, it takes both of them as the input. Like baseline data is one of the input, the target data is one of the input over there, and it finds the drift between them, the drift in the data spread, or you can say drift in the data itself. So if there are columns like x1, x2, x3, right, and x1, x2, x3, and how do you do this? uh, you can do it from here also. Data set monitor. This is a data drift monitor. The full name is data drift monitor. We'll say create. Now you have to give all that, the source data set, like this, and then you have to give the okay. So now if you see what it is doing, it is saying that do you want to compare this same data set with the same data set but with from a previous period over there, or do you have a different baseline data set? So you can do any of that, right? Now we have a baseline data set. That's what we have. We would like to compare with that one, the one on which we have done the training. So we have to select the other one. If once we do that, what it will do is it will run on the schedule. It will require some compute. So you have to define you have to use the compute. It can be that same compute, that green one over here. It can be something else uh, altogether. Now it will give us a drift in percentage as such, like how much has the source, uh, the pink one has drifted, the yellow one has drifted from the pink one over there. And that drift will be available in percentage term, like some 2% drift, 5% drift, some X amount of drift, and so on and so forth over there. And it will also give us the overall drift, like the entire data set has drifted from the other data set by some percentage, maybe 10% drift or 30%, 40%, and so on and so forth. So whatever drift percentage, and there is a threshold which you have to define. So if the threshold is more, you can say if the drift goes beyond the threshold, then it will basically alert you. We can re-trigger the model training as such. Uh, so this is and it's in preview right now. It's not totally out for production as such, but this is the one which we have over here. So analyzing drift between the various, uh, you can say data drift for the various processes. And there are some scenarios you can read from here, like in which scenarios it does the data drift as such, and uh, what is target data set, what is baseline data set. I'm pretty sure it's very clear, but that's the usually the training data set, usually the inference data which is coming in. And how do you define it? So you can automate it. I haven't done it yet on this in this scenario. I leave this up to you to be configured as such. And this is how it looks like. This is what I was explaining, that the overall drift is there and some 20% threshold is there. So beyond the threshold, then then it will inform you that the trend has changed, some weather has changed, and how much drift has happened, and so on and so forth. Okay, so put your questions in the chat, right? I can see one hand. Put your question in the chat. Okay, so now the last thing which I have configured over here for you guys is the little bit of IoT over here. Just want to close the session with little bit of you can say IoT deployment. So this is the MLOps pipeline. If we recall, revise it. So what we have done is the wide world importers basically wanted us to set up the MLOps pipeline for them. So what are the major things which we have understood is we need the repository, we require the agent, we require the thing should be versioned as such. So what we are versioning is the steps can be executed sequentially, steps can be executed parallelly over there, and just want to show you something over here which I didn't showed you earlier. So this is where we can leverage the cloud as such. Like there are different technologies are good for different stuff as such, like use cases of Hadoop, Spark, and everything. So if you can see over here, you see this. We have various type of steps, like AutoML step is there. The uh, the if you know what is Azure Batch, if not, this is HCI, high performance computing or clustering. This is that. Data transfer step, data brick step is there. Estimator step is there. Hyperdrive is the hyperparameter tuning algorithm framework which they use, Hyperdrive. So that step can be there. So this, you see this green step can be of different type over there. MPI is message passing interface for your distributed machine learning. Parallel run configuration step is there. Some R script step is there. Synapse Spark step is there. So various type of steps can be there. Things are modular. Things can be reused. You can plug and play the data sets and the steps. Uh, the one which we have right now with us is this one, Python step over there. So we have used that Python step. Which statistical metric is used for getting the data drift? It's a model comparison. So what they do is they train a machine learning model, and that machine learning model finds a difference between these two drifts over there, and the drift is provided in terms of magnitude as such. So whatever, it's not any spec. It's a model-based drift detector. That's what it is. It's not any other. Uh, uh, like we have various type of matrices which are used for data drift, but it's a model-based data drift detector. So it's of that, and it will give you the magnitude difference between these two. It just finds the percentage drift between them in whichever units or whatever magnitude is there. Okay, so if I take you back over here, so dataset versioning, the code versioning with build numbers and so on and so forth, artifacts, uh, the CD pipelines, the continuous delivery, continuous deployment, ACI, AKS, and then finally the data drift monitors and so on and so forth. So the last thing which I just want to show you is pretty interesting over there. So what happens if your production location is not uh, Kubernetes in the cloud? It's not that, right? You're saying that deploy it on the IoT edge, then what do I do beyond it, right? So if you have to deploy this on the IoT edge, then here some extra things are going to happen. So if wide world importers want to deploy this on the IoT edge, they first of all need the IoT edge itself, right? So which I have with me as a Raspberry Pi uh, with me, and I will just connect with it. So I have connected the Raspberry Pi. Let me connect with it. So it's right now connected to my laptop over with a LAN wire, with the Ethernet wire, and as Raspberry Pi local. I think that's the name. Okay. So this is the Raspberry Pi. So now this is this over there. So what happens if that needs to deploy here, right? So how do we do this? So first of all, we need the hub, the IoT hub over there. So you have to create this IoT hub first. So Azure IoT Hub is basically a Kafka cluster, which is having it's supercharged to have the IoT functionalities. But at the heart of it, the core of it, it's a Kafka cluster. So, but this is the IoT Hub right over there. So, uh, if I take you to my Azure portal, and if I click on all resources, I did make that somewhere. That's the one. So this is the IoT Hub. You need to deploy this first. Then you click on the IoT Edge over here in this tab, and then you have to wait for it. Then you have to register the IoT device. So let's say this one. Now, what type of device, what type of authentication do you want to have? You can say a key-based or certificate-based. For mass deployment, certificate-based make more sense. Uh, you have to have the certificate first to be able to do that. So this is your, for example, it's not showing here. Hang in. Let it come. Let it get deployed. Created a device. We just need a full page refresh. Okay, fine. So you create this MyPy, let's say 2. Then we need the connection configuration over here, this one. So we'll copy this and we'll open a notepad and we'll save it somewhere with us. So something like that. Now we have to open the documentation of Microsoft. So I will just open the documentation. I had it open somewhere. I kept it open with me. Okay. This is documentation of Microsoft to do this. Yes. And this goes in the chart window as well. If you if you can see this, that is certificate based. You can follow that also, right? You need to have the certificate over there. So you can sign up for the one sign up. You can self sign the certificate. Otherwise, deploy one ADCA, right? Deploy certificate authority and get the certificate from it or pay for it. So basically, what you need to do is what I have with me. Just give me a second. Let me just reorient myself. Where is it? Okay, so this is what we have done. We have created the IoT Edge. Now, what I have with me is a Raspberry Pi 4 Model B. That's what I have. This one, the Model B. It's plugged in right now in my laptop. That's the one which is over here. That's the one which we have connected to Pi at the rate Raspberry Pi. This one, and the so what you have to do is, and you need to have the operating system over there. So if I open that same link again, you see this image. You see behind this, the back side of it. Basically, that's where the SD slot is there. You have to put the memory, the SD, the SD card over there behind it. It will be just on the flip side of it, the opposite side of it. Maybe in one of the diagram, it might be in one of the image, it might be there. But what you need to do is, so you basically need to have this, the imager with you. So you need to choose the operating system. Which operating system do you want to install in the Raspberry Pi? It's a microcomputer. So I have this one, Raspberry Pi operating system 32. But if you want to go for something which is more, you can say, Ubuntu options are also there. You can click on it. Uh, Something should load in some time over there. And we have other options as well, which will be, I can click on this one, then it will show me more options. So, okay, now you basically select the operating system from there. You select your SD card. You need a SD card reader as well. And you have to put that SD card in the card reader and put it in the USB slot. And you choose that slot from here. It's not connected right now. Then you basically, I need to click on one of them. So let me just click on one of them. Hang it. I just want to show you one more thing. Okay. So then you set it up, like the name of the Raspberry Pi. So my Raspberry Pi name is pi at the rate raspberry pi dot local. That's the default configuration which I have. Pi. It can also be Wi-Fi connected. So that's my Wi-Fi name over there. So right now it's connected over the Ethernet cable. Okay, so you have to have the imager. You put the SD card back in the Raspberry Pi, plug it in, and so on and so forth. Finally, it will open up, right? Over there, you can take the SSH. Now, once you have taken the SSH of it, then what you have to do is you have to follow this from here, from that point onwards, from this line. In the Raspberry Pi, see, what we want to do is the image will be deployed there. So the first thing is you need to have the Docker, you can say, environment over there. So the engine, so that Docker engine is a very lightweight engine over here called as Moby over there. So this Moby engine is going to be installed here. So Moby engine will be installed over there. Now, if you're thinking of something very fancy, you want to do some sort of AI in the edge itself. Your edge device should be very powerful in that sense. So you can go to this thing called as a Azure IoT Edge catalog, and you can buy the hardware which is certified by them. that it will work with the IoT Edge and so on and so forth. This link goes in the chat window over here. Now, as such, so you can buy something which is more industry grade from here. But once you have done that, finally, this is the Docker engine over there. So the whatever you are running is running on that Docker engine as such. So what we need to do is the artifact which let's make one more box here. So one thing which I think I skipped over here is that there's a concept called as Azure container registry over here. This is called as ACR. What it does is it saves the Docker images over there. All the images will be there. So the image is the one which is having all those things as such, right? So this is the Docker image as such, like this. So what we want to do is we would like to connect the IoT Edge solution with the IoT Hub first. Once we have done that, we would like to deploy a configuration to the IoT Hub over there. Now, in that deployment, so what happens is that deployment, that configuration will be pushed to the IoT Edge over there. So imagine this is a deployment of the configuration. If everything is correct, which we have done, what will happen is the images will be pulled from here. The images where all the stuff is there, those images will be pulled from there uh, as such, and those images will be you can say with those images the containers will come up here. So this is where the model will be will be running uh, somewhere over there. So maybe there is a camera module, so we call them modules. We have to design the modules over there. So how do we do that, right? So this part will install the Docker engine in the Raspberry Pi. uh, Once you have done this, you simply scroll down, skip all of that. This is the IoT Edge. You need to install this this is the SDK for Microsoft IoT, for the Azure IoT Edge. This is the one which will make it work, right? Now, uh, uh, we are doing the key-based authentication. So it's hard coded. There is for now you can do the other one, the certificate based one as well. It's in the link. But basically you copy this key from here over there, and you go back and you give it in that configuration which was open here. Give it here as such, and run this in the IoT. So we are doing a manual enrollment, otherwise do a certificate-based enrollment, and you run this. So if I show you maybe this part over here, so what it does is, let me see if everything is healthy or not. Let me just quickly see if the containers are still running. Oh, sorry. Okay, so otherwise I will troubleshoot the container first, then I will show you the next part. Yes, the container is running, classifier is still there. Okay, great. So, okay, so if I show you what I just copied from there, let me see if I can zoom in here or not. Okay, so this, what it basically does, it applies this config on that. So if I do run this, it will just say redeployed. I'm just going to paste that. I'll run it. It says that it has been reconfigured. Services are restarting, and generally doesn't take that much of time to restart, but maybe it's not, something went wrong. We'll see. So then this is the one of the major part. So what we want to see is like, what is the status of the you can say the agent which is there in the edge. So it will say that okay, everything is running. So if I show you what's the and if I just show you the Docker containers which are in the Raspberry Pi which are there right now, it will be okay. So I think that's why it was taking some time. It got restarted. It will I think it will show in few seconds now. But if you see this one over here, uh, so the concept is, you see this IoT Edge Hub, uh, and we have this IoT Edge agent over there. These are the two things which are there. So there are two containers which are running, apart from the one which we would like to deploy. One is the edge as such, and the other is the hub over there. They are not supposed to be on the same machine. I only have one Raspberry Pi. You can have a different configuration as such. So this is the edge right now, and that's the hub. Both of them are on the same Raspberry Pi. But the edges can be multiple, and they might be talking to the same hub, and then it might be talking to the cloud. So now what we want to do is the configuration needs to be done from the Azure DevOps portal. So if I take you back to the Azure DevOps portal over here, and if I zoom out and if I click on the releases as such, sorry, on the pipelines over here, I have kept this ready over here with me, deployed to the IoT Edge as such, this one. And if I can click on if I can go one page back, I will just see if I can edit it. And one thing which I have done here is just want to show you that the IoT Edge modules are available, like steps are available. So there are three things which we have to do. Build image is first, push image is second, third is deploy to IoT Edge over there. So build, push, and then deploy over there. The build process and all of this is already done for me in my configuration. That part is already done. The image is already there, uh, and I'm doing the deploy part over there. So I have not done the first two parts over there. So similar concept. The install the Azure IoT Edge in the Linux machine this time, and then uh, and then inline, what we are doing is that's the name of my device called as MyPi. That's my IoT Hub name. Parameterize it. There's the configuration file which is actually getting deployed right now. So that file actually is over here, and I will just walk you through that one. I have kept it here. So this is how that looks like internally. So it is having the information about that yeah. In this one, I have not literally things are hard coded here right now. Didn't have the time. Just wanted to put that in place. So just have kept this extra thing for you guys to have a look at this. Okay, so this is the agent. 1.2. That's the hub uh, as such, and that's my classifier right now. So this is the Docker classifier which I have, uh, and this is the one which is there in my container registry over here. This one this location. So that's what is getting, you can say, defined to be pulled over there. This is extra. I should have removed this. I took one default template. This simulator came with it. It's not required for my scenario right now. But this is the module, the classifier module over there. Now, the configuration part of how it is supposed to be done is actually on this page. So I'll give you the correct links to follow because I have just shown you a part of it. But I think this is the correct page. So it goes in the chat window over there. So if I walk you through this, you have to install a couple of extensions in the VS Code. That's your new project. For example, some classifier needs it's getting created here. Uh, this is not exactly what we are doing, but this is using custom vision. And in one of the previous session, I think we have already talked about this sometimes back. Maybe that event was not for Reactor, maybe it was for something else. I'm not exactly sure, but we basically can skip all of that and we can start from here. That you need to have your VS Code in place. So, for example, you need to install the extension. So, if I walk you through a couple of things, you need the new IoT Edge solution. You need to specify which target are you deploying for. Is it Ubuntu? Is it Raspberry Pi? And Raspberry Pi, then which one? Model 4, model, is it the third one? Um, and so on and so forth. And how many modules do you have? So, for example, I have only one module, the classifier. That's my Docker image right now for this classifier. And the this is actually also connected to that same Raspberry Pi. It's showing that the classifier was running earlier. Now it is unknown, but I think I just restarted everything. So you can follow this module, and if you just scroll down, you can find you can use this along with what we have discussed to deploy the MLOps step over there. Now, the last thing which I want to show you is I want to give you the links of how you will follow what I just showed you uh, after the session. So I am just going to give you the repository link in the uh, chat window. Okay, so whatever we have done is documented over here, uh, over there. So this link is there in the chat window. The last link, if you bookmark the last link, that's where that's what you need to do. So you can click on the hands-on after that, and it's part A and part B over there. Part A, and then part B as such. So it's a Microsoft workshop which we have deployed. So there were a few corrections. So I have done the corrections over there. A few things were got changed. So you should not face any problem. Everything should be perfect. And that's whatever we have done. It's documented for you. Uh, you can you need to have Azure subscription. That's one thing which you need to have. That's what we have deployed uh, as such. And you can follow these steps over here. And basically, the entire MLOps pipeline will get created. It's not explained as such. The code is not explained over there. For explanation, you can check out the YouTube video. So whatever we are doing is also will go on YouTube as such. So you can simply go in. When you do it, you can just walk through the code along. You can play the video again and you can go through it, right? So this full process is documented there, right? The last one. Please do bookmark it. Okay, so let me just quickly take your questions and uh, so the data drift monitor link I may or may not have given earlier, so you can go and have a look at this. It's a model-based monitor. So this is the one, AML, this one. Will the model run on IoT Edge? Yes. Yes, it will run on IoT Edge over there. Yes, here. It's right now, this is the model. Uh, this is the one. That's the one. Couple of extra things also needs to be done for IoT Edge, right? For you, if it's a camera, like camera input, that camera input and all those things, it's not. We have not done it. It's not our requirement right now. Just wanted to show you, like you can in the same pipeline, you can also put the IoT Edge deployment as well over there. How do we do the retraining and push the new model to the IoT Edge over there? Okay, so now first of all, same concept. It's a bi-directional communication. So the instrumentation key which is here, it is going to do the model logging for us. That's the first thing. So the logging of the data, the same concept which we have used earlier. So this is going to log the information like that. It doesn't happen in this way. It basically push it back to the IoT hub, and then IoT hub is the one from where we get it. So you can say something in this way. It goes here, and then we sort of enable the logging. That's one thing. That's how we will come to know that it got. You can say it got uh, drift is happening. That's one thing. Now, how do you redeploy it? It's uh, we'll just read the file again. See, you have to specify the path of the image correctly as such. So this is the path of the image over there. So this is the image which is right now in that location. So over here. So for example, if I have like version one and now let's say version two later on, which I'm getting, I'm doing there. So let's say uh, this is not what we are doing. Last step is the IoT deployment over there. It's not this one. So the latest image, the version which you have, will be pushed and deployed over there. So first the image will go and the container will come up. So redeployment is the easier part, like this. This should be correct. Your image should be somewhere like that in a location like this. This ARM32 depends on the Raspberry Pi version. So my version doesn't support 64-bit because of some reason. So I use this ARM32 version 7, which is my Raspberry Pi hardware, you can say. It's 32-bit ARM32. And this should be uh, in your ACR. So should be somewhere in the ACR somewhere here. So in the repository section like this. This one, last one, classifier. So this, uh, that is actually that, the top box over there. Can we input the image data from any device like mobile and give as input to model running in AKS and get the result? Uh, okay, so this is just, so first of all, just want to reiterate that this is just was showing that that can also be done. Uh, our logic is totally complete till Kubernetes, but if I read the question again, that mobile device and give the input. Yeah, why not? So you basically you're talking about an API call. That's what I think about over here. So you see, it's actually already there. Like for example, if this was image classification, so it's totally consumable. I can click on model endpoint and I can click on uh, this is my model which is in Kubernetes right now. And this is the API endpoint of it. That's the API endpoint. That's the key over there. So for doing the inferencing from mobile, you need to have some app which can do the API call or something. If you want to test it out, just use curl, right? Curl can do that. So this is the API endpoint. So use curl. Curl can also send the image as well over the API calls can happen. So or you can upload the image somewhere and give the URL. Anything is possible, and you will get the response. If it was image classification, we could have done that API call with curl or with mobile app. Yeah. Okay. So the let me just scroll to the top. Okay. Okay, so I guess you guys have kept everything with you, right? The link, the GitHub link, that's where the documentation is there. Whatever we did is there. Code is not explained. To explain the code, you can just find us on the YouTube link. The video will be uploaded in few days over there. So that link is in the chat window. Rashmita has just pasted that. The Reactor YouTube page, the third link which is there, and that's where the recording will be uploaded. And you can find me on LinkedIn. And if you have any questions when you do this, uh, ping me on LinkedIn. As such, my LinkedIn profile is there in the on the meetup page. And it's I'll put that in the chat window as well. So do put your do find me there. The last link is there. And if you have questions in ML, I'll be happy to answer them.
We'll just wait for another couple of minutes and wrap up the session for today. In the meantime, I'm displaying my screen where you'll find the survey link with the event ID and today's Learn module link. Please feel free to, use the Learn module link. And I've also shared in the chat section. This will only give you access to additional resources to take your learning further. Also, please bookmark the links which Shivam shared in the chat. Please do share your feedback. It always helps for us to curate the topics for the future sessions. And also please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. If we don't have any more questions, then yes, we'll wrap up for today. Thank you, Shivam, so much for the session, and thank you all for joining us today. Thank you and enjoy the rest of your day.
Thank you, Rashmita. Thanks, everyone. Have a nice day. Have a nice week.